You said it, Jason.
Yeah, everyone agree with that? Chemical monitoring and management, the CFC question at the front. Is that a consensus?
Yeah.
Like twice already.
Yeah.
Alright, so the question is, discuss problems associated with the use of CFCs, analyze their effects on the atmosphere using appropriate equations, and there should be evaluate. It's missing evaluate in that question, so just write it in. Yep, chemical monitoring, that first long response question. It should be and evaluate the effectiveness of the steps, right? Yep. So discuss problems associated with the use of CFCs, analyze their effects on the atmosphere using appropriate equations, and evaluate the effectiveness of the steps taken to alleviate this problem, right? So this is a fairly old CSSA question. And actually, me and Stephen were reading the answer. It's not a particularly good answer, especially considering kind of the standard that answers are. You can kind of see that the answers have improved over the years, right? So me and Stephen have come up with kind of our own criteria. So the thing with long response questions, right? People will often, what happens often is people will, 7 marks, crap, that's a big question. I'm gonna have to write heaps. You panic, we've all been there. Oh crap, I've got a whole page, I've got 2 pages, I'm going to have to write heaps for this 7 marker, right? The key is knowing what content they are looking for. If you write content they're not looking for, you don't get any marks for that. Even if your answer is shorter, you do exactly what the markers are looking for in this question, right? So, first thing you should do is you look at the key verbs and the key terms of the question. So clearly it's discuss, analyze, evaluate, there are my key verbs, right? And then the key terms I've got problems and use of CFCs, effects on the atmosphere, and steps taken to alleviate the problem. Yep? Right. So if I look at my key verbs, discuss, which is identify issues, provide points for, or, and against, right? Analyze is identify the components, draw a relationship between them. This is all the HC glossary, yeah? And evaluate is make a judgment based on reasons for or against. Sweet. Yeah, this is all making sense? Yeah. All right, so first, what I like to do when I'm doing this question is I like to map out down the side what I'm going to write about. And actually what I do in exams is when I'm going through, if I get to a long response question, because the way I think doing a long response question is different to the way I think doing calculations. So when I go through, I hit a long response question, I go bang, 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 I put my marking criteria down the side, I don't write my essay then. I move on to the next question, do the same thing. If it's a long response, bang, bang, bang down the side. I've got my own checklist to come back later. If it's a calculation, I just knock it out. Because I think, in my opinion, I think different questions require you to think in different ways. And I don't like to kind of interrupt my flow and then go back and forth. Do you kind of get what I mean? Yeah. So what I would do when I hit this question, I look at all my terms, and then I put the points down the page, then I basically just write it out. It's too easy. But discuss problems associated with the use of CFCs. So what's the use of CFCs? What were CFCs used for? CFCs?
Refrigeration.
Refrigerants.
Aerosols.
Aerosol
Propellant.
Right.
Same thing.
And I could say coolant, but basically a large variety of uses. So why were CFCs used? Because they were stable, unreactive, in that form, right? So this is my use, and now I need to say discuss problems associated with the use of CFCs. So I need to say, and they were used for this purpose because CFCs were stable and unreactive. And you could also say, you know, the things like they had the high heat of vaporization, so they were being used for coolants, but that's kind of specific to the purpose. And it's not for propellants either, so you don't really have to say that, right? Stable and unreactive. Now the thing is, in this question, because you have problems associated with the use and effects on the atmosphere, if you think about it, the problems associated with the use is its harmful effects on the atmosphere. So you can kind of actually knock 2 birds out with one stone. While you're analysing the effects on the atmosphere, you are discussing the problems associated with the use. The only thing is, you have to draw the links between how this used goes into the atmosphere. So you've got to fill in what happens up here. You can't just jump into the effects in the atmosphere, right? So what happens up here, I've got, because, if you've got propellant, you're literally spraying into the atmosphere.
Still going.
Alright, lad.
We nearly finished. This is our long response question. Right, so refrigerants and propellant into the atmosphere, right? So you've got to say what happens. Because it's stable and reactive, they don't react in the troposphere, but over a period of 50 years, diffuse into stratosphere. Yep.
And I also mentioned that because it's a non-polar substance, it doesn't dissolve in water. So even if it rains, it doesn't fall back into the ground. So it will just keep going up.
Yeah.
Continually.
So, for example, like carbon dioxide reacts with water. That's why the oceans are such a big carbon sink for our carbon dioxide. But our CFCs don't react with water, so we don't have a water or rain being able to wash our CFCs away. Make sense? Right? And also, so don't react air or water. Yep, got that? Now we have to analyze their effects in the atmosphere. So effects on the atmosphere, so we've already said they don't react in the troposphere, air or water. Yep, now we have to say they diffuse into the stratosphere. And that's where the problems occur, because ozone destruction. Yep, got that? So now we have to analyze the effects. So how does this ozone destruction occur? Because we have our chlorine-free radical or our bromine-free radical, and we've got to have those equations. Because especially it says using appropriate equations, right? So,
And equations, it says equations, so that's S. So whenever you see S, like chlorine, you just circle it. That means more than one. Right.
true, that's true. It's kind of a hint to say there are a series of equations that you need in your answer, right? So, do you remember your equations for chlorine-free radical and why that it can keep destroying ozone?
Chlorine. Oh, you have to say like how it splits into chlorine for radical.
Yes. So let's just give an imaginary. So when you say CFCs, such as you give an example. So when you have your equation, you have an example, right? CFCs. Just use a simple one. CCl3F. Simplest one you can get.
3 on 12.
You don't.
Can't you do like dibromo difluoro? Oh no, dichloro.
Just write CCl3F.
C-clef.
That's all you need.
C-clef.
It doesn't matter which
I
one.
memorized it as
Doesn't
C-clef.
C-clef. Good.
That's nice.
Anyway, so right, CFCs such as CCl3F, right? So now I have my equation. CCl3F, 2 CCl2F, free radical, plus chlorine free radical. Oh, yeah. And that's UV. Stephen. Is this UVB or UV?
It's UVB or C.
I think it's mainly UVB. UVC is stronger, isn't it?
So it's slash C.
Sure.
Doesn't matter.
So
You should say that. You should say at least you should say UV.
Do you need a wavelength?
No, not necessarily. At least you have to say UV. If you want greater detail, and I think if you're a band 6 student, you should be able to know the extra detail. You know your UV, what your UV is, right? So that dissociates into my free radical and my chlorine free radical. Yes?
Yep.
Right. Then I've got my equation. Cl free radical plus ozone becomes ClO free radical plus O2. Right, and that is my destruction of ozone, where my Cl free radical destroys ozone, and you should have a bit of explanation in between, right? You don't just list your equation; you have to explain why, because it says specifically analyze the effect. So what this is, you have to say my CCl3F is broken down or dissociated, broken by UV in stratosphere.
Or it's also called photochemical decomposition.
Yeah, exactly. Right, so I've got my Cl free radical, ozone broken. So now I have to say here, my chlorine free radical destroys ozone.
Oh, we're almost finished.
Yes, we're nearly done here as well. Right, so this is my Cl free radical, ozone, destroying that. After that, I've got my ozone, my chlorine free radical regenerating itself. So ClO free radical plus O free radical becomes Cl free radical plus O2. Cl free radical regenerates. To begin process again.
And if you're wondering where that O radical comes from, is in the troposphere, when the ozone protects UV, B, and C from us in the troposphere, it continually breaks down and reforms, so it becomes O2 plus O continually, and that's where that O free radical comes from.
The Chapman reactions. You should know those. I think this question doesn't require you to say that, because if you were to say compare the effects normally, you would have to say what happens normally in my Chapman reactions, which is ozone is broken down to oxygen and my oxygen free radical, and they regenerate themselves again. But it says specifically analyze their effects in the atmosphere. So we say here, my chlorine destroys my ozone, then it can regenerate itself, begins the process again, and it can happen hundreds and hundreds of times from one chlorine free radical. That's my effects on the atmosphere, that my chlorine can destroy plenty of ozone. Make sense? Now, I've got my last part, equate and evaluate effectiveness of the steps taken to alleviate this problem. Right? Whoops. So, my
Mention to them that I forgot to write the value.
yeah, I've got it.
But are these all the equations that are needed?
Yep, because it says analyze the effects on the atmosphere using appropriate equation. This is the effects of chlorine-free radical in the atmosphere.
So we don't need to write the effects of the CCl2F free radical as well.
It doesn't really react that much in the atmosphere. It's not the important part. The important part is chlorine-free radical destroys ozone, regenerates, can do it again, regenerates, can do it again. That's
What are the chapters again? It's O2 plus O right here, and then
so you've got ozone associates from your UV, then you've got your free radicals joined together to become ozone.
this is like this, right?
UV samples.
You've got it's O2 I think it's basically O2 plus free radicals.
They couldn't determine the same they both do it, but
This is
maybe
what I've been doing wrong. Oh, this is what writing down so not writing
a lot of people like before UV.
Was that the name?
And that's our Montreal protocol. Sweet.
What year?
1989. Yeah. January 1st, I think. Stevens.
Wait, wasn't it 1987?
87 or 89? I think that's true. 87. I think it's 87. Alright.
So when you talk about introduction of HFCs and HFCs,
Yeah, that's what
It says evaluate the effectiveness of the steps. So of course you're going to have to describe the steps taken, right? Steps taken. So what are the steps taken?
Montreal.
Steps. Montreal.
Would you yours?
1987.
HCFCs?
What if no? To summarize what the Montreal Protocol is, basically phasing out our CFCs and strongly. Do you remember ODP, ozone depleting potential? Basically phasing out our strong ODP chemicals. That is our Montreal Protocol. And then, as a side effect of that, they have to say we're going to introduce alternatives because you can't just, get rid of all our propellants and refrigerants that we have in the world. Right? Does that make sense? So Montreal 1987. So that is phasing out. Phasing out high ODP,
what's what you do again?
ozone depleting potential. Ozone depleting potential. Yep. High ODP substances. Right? Yep. And then introducing alternatives.
And very good.
Sorry? What? No problem. Right. The last thing we have to do is evaluate the effectiveness. So we have to say how effective it is. Right. These are our steps. Now we say how effective they are. So you should know kind of in terms of the statistics, right? and I can't remember which year it is. Was it 2000 I think about 2005. Scientists had predictions to say by this year our ozone levels will basically be back to pre-1970 levels, and by this date our ozone levels have stabilized. I think it was 2000 they said that our ozone levels have stabilized, and they said I think by 2050 that they will return to pre-1970 levels. I think that was right.
For the like introducing alternatives, you say like CFCs.
You can?
Would you have to provide an example?
No. Because you got to look at the question, right? This is the thing. You can't just say 7 marks, I've got to write a lot. Is that information helping me to answer this question? Evaluate the effectiveness of the steps taken to alleviate the problem, right? But you should say with the alternatives, we don't have very many viable zero ODP substances. Most of the alternatives we have are just significantly lower, but they still deplete the ozone layer, right? So we say, you have to evaluate, so that's personal, that's what you think yourself. Some people will say, it's completely effective. What I write in my answer was that it's very effective as a short-term solution. As you can see from the predictions and by the statistics that it's stabilized by this date. Yep. But because the substances that we have still have ODP, we have to say that as a long-term, we have to find zero ODP chemicals to use as our refrigerants and propellants. Does that make sense? And I think that's our 7 marks in this question.
How, for your little notes on the side,
Yep.
like it'll be much more, a little simpler than this, right?
Well, I've been putting everything that I'm going to write on the board. So I've got like.
Like this would have taken a while to do, like, right?
But when you're writing your question, when you don't have to think about it, it will save you time. Just trust me on that. So when I've done the exam, like, after I've done this, it might take me, 5 minutes to write my whole thing.
Doesn't it take a lot of space as well? Like if you're gonna write all that.
This will all be on dot points. I wrote extra stuff. Like in the exam, I won't write all of these. I'll just say my ozone depleting equations, right? On this side, I'll say, my uses, save one reactive. I'm not going to have my flow diagram going everywhere. It'll just be dot points down the side. It doesn't take much space. It takes some time, but you get that time back. It's a worthwhile investment. Make sense? All right, so. Cheers, guys.
Thank you.